Hi, I'm Tom Fury, the CEO of SageTech Avionics, and today I'd like to talk to you for a few minutes about detect and avoid technologies and as requirements as they exist today. For the FAA, for NASA, and for most companies in the UAS space, full integration of unmanned aircraft into the National Airspace System is a high priority. Detect and avoid systems remain a critical technology to enable that full integration. For unmanned aircraft that are operating above 400 feet in the national airspace, they will typically be operating under FAR Parts 91 or Part 135. They will therefore be equipped very similarly to manned aircraft. There's one difference that's unique to UAVs. Under FAR Part 91, the FAA makes it very clear that the aircrew are ultimately responsible to see and avoid other aircraft. With unmanned aircraft not having a pilot on board, it falls upon a detect and avoid system to be able to maintain that the aircraft can be seen and can see other aircraft and avoid those. A point of confusion we often run into when discussing DAA with customers is UTM, or UAS traffic management. The FAA and NASA are working together to define a UTM system where below 400 feet in certain areas, unmanned aircraft will interoperate in a system different from the overall air traffic management, or ATM system. Unmanned aircraft that are above 55 pounds, flying above 400 feet above ground level, will typically operate under Parts 91 or Part 135, will require similar equipment to manned aircraft, and will require either ACAS XR or ACAS XU based detect and avoid systems. So what makes up a detect and avoid system? A UAS will typically encounter two different types of traffic: cooperative, which has a transponder on board and will usually have an ACAS or a TCAS system on board, and non-cooperative traffic that doesn't have a transponder on board, or it has a transponder that is not operational. Cooperative traffic will provide ADS-B signals. It's important that the UAS then validate those ADS-B signals, since ADS-B is dependent on GPS, which can be easily spoofed. A typical method of validation is through active surveillance or an onboard interrogator. A radar system will detect non-cooperative traffic, and then the tracks from the radar and from the ADS-B receiver will be fused together as part of the DAA computer. Traffic advisories and then resolution advisories will be given to the UAS via the threat resolution module if a collision is imminent. And then that DAA computer will provide the information on resolution advisory commands, either to climb, descend, or turn, to the transponder so that other cooperative traffic will be aware of the UAS intentions. So with all of those components, one of the challenges for DAA right now is that there are many component level standards and TSOs required. Also, with all these different components, size, weight, power, and cost of these systems are large, and reliability is critical since these are life-dependent systems. And right now, significant work is being done to take those independent components and integrate into individual systems. I won't get into the details of this eye chart. However, the RTCA is working right now through 3 different phases of completing the MOPS, or the performance standards for equipment requirements for detect and avoid. Phase 1 has been completed, which defines the equipment requirements and performance requirements for entering into and operating in Class A airspace. Phase 2, which will be operating in Class D, E, and G airspace and transiting other airspaces to get there, will be completed next year in the spring. And then finally, for special use cases such as HAPS, high altitude pseudo-satellites, for Part 135 cargo operations, and for VTOL operations such as UAM or AAM, those requirements will be completed over the next year. As discussed, today DAA systems can be created using discrete components. SageTech is working with many customers to integrate our MXR interrogator for ADS-B reception and validation, and our MXS transponder, along with off-the-shelf radar components, and then either customers or partners' DAA computers for track fusion, threat resolution, and providing information to the operator or to the flight computer. In the future, we'll see these components integrated into single certified off-the-shelf systems. That'll help greatly with simplifying the safety case for type certification of aircraft, and we'll see continued reduction in swap of these components and systems. If you'd like to talk more or learn more about detect and avoid technologies, feel free to follow SageTech Avionics on LinkedIn, follow us as @SageTechAV on Twitter. You can log into our website at sagetech.com, or you can contact me directly. Thanks, and have a safe flight.